So I'm going to go ahead and get started. All right. So good morning. Thank you for joining me. If you weren't able to attend my session yesterday, my name is Jeff-Wierer. I'm a principal product manager on the Identity and Access Management team. And today I have the pleasure of talking to you about delegating access to your AWS account. Now, as you use your AWS account, you're inevitably going to have to share resources with others, whether those are members of your team, business partners, third parties. What I want to do with you today is take you through a number of common use cases that I encounter as I talk with customers and give you some strategies and some samples of how you can actually go and achieve those. So this is going to be a very use case driven and technology presentation. So here's some of the goals for the talk. There's a number of scenarios I'm going to go through. How you can do cross-account API access, sharing access across multiple AWS accounts. I'm going to cover federation in terms of single sign-in to the management console, as well as API federation. I'm going to end the presentation with something that we call Web Identity Federation, something we released just earlier this year. There's a number of different terminology and technologies that I'm going to discuss. So I'll probably use the words session and temporary security credentials interchangeably. I'm sorry about that. You request these by calling the security token service. For the rest of the presentation, I'm just going to call that STS. And then we're going to talk a little bit about roles, how you assume roles, federated sessions, and get federation token, what some of the differences are, and some of the ways that you get temporary security credentials. So I think the best way to probably introduce this topic is to start off with a short demo. So let me just set this one up. And this is actually, if you want to follow along, you can actually download this code sample. It's one of them that I published last year. So if you want to play with the code afterwards, there's also an MSI that you can just use to deploy it if you want to see it. But the way this demonstration works is I'm going to log into a Windows desktop. This is actually just going to be an EC2 instance. And that instance also has a domain controller. It's running Windows Active Directory. I'm going to be authenticated by Active Directory. I'm going to then go into this proxy server that I'm running. It's just running within my instance. I'm going to log in. I'm going to choose a role. And then I'm going to single sign into the management console. And I'm going to do that without using a username or password. Okay? So let me show you what this looks like. So as I mentioned, you can download the sample. This is actually the download page. When you get the sample, there's documentation. There's the source code. It's just a Visual Studio project written in C#. And then I also have this MSI. So if you're not a developer and you just want to play with it, this MSI will just deploy a package site that you can go and you can do the same demo that I'm going to run through. What this does is installs a website. This is running Microsoft Internet Information Server. So I have my console proxy sample here. If I just click here to browse to it, I'm going to get to this page. And then from this page, it knows who I am. So I'm using Windows Integrated Authentication. So I don't have to provide a username or password. It knows that it's me. This is my alias. And then there's this drop-down menu with these two options. It says AWS admins and AWS S3 users. So the question is, where did those come from? All right. So as I mentioned, I'm logged into my instance, and I'm running Active Directory. So this is my account. And if I look at my account, I'm a member of a number of groups. Now, two of these I want to point out. One of them is the AWS S3 users group, and the other one is the AWS admins group. Okay? The second part of the configuration that I have is actually in my AWS account. So for this demonstration, I'm leveraging IAM roles. And in my account, I've created two roles, AWS admins and AWS S3 users. And the sample simply goes in, the proxy server goes and looks who I am, says this is Jeff. What groups is Jeff a member of? And then what roles exist in my account? And the way that I've built this, it just does a simple name mapping. So it looks at the intersection of those, and it says if there's a group that matches a role name, populated in this list. And then as a user, I just select the role that I want. I click sign in, and I'm in my account. I never have to provide a username or password. All I have to remember is how to log into my Windows machine. So hopefully, if that's the type of solution you want to learn to build, you should stick around for the remaining 55 minutes. So I went through that kind of fast. So what just happened? Well, I logged in my Windows desktop. I hit an intranet website. I chose the role I wanted to play, and I automatically signed into the console. And that's it. No username, no password. So let's figure out how do we build those. The way that we build those is based on sessions, temporary security credentials, and you get those from the Security Token Service, STS. So sessions 101. This is the basics of how you delegate temporary access. Everything I'm going to show you today is going to be based on sessions and temporary security credentials. You get these by calling STS. STS is, you can think of it as a ticketing system. It generates tokens. It generates credentials that you can use. You then take those credentials and you use them to make subsequent calls to other AWS APIs. This is how it works. You start by requesting a session from STS. When you get back the session, it has a certain number of elements in it. The three elements you want to be aware of are the access key ID, the secret access key, the session token. I'll refer to these as temporary security credentials through the presentation. You use these keys to sign AWS API requests. You're probably already familiar with your root credentials or the long-term credentials you get from an IAM user. That's an access key and a secret access key. The only difference here is when you're making requests, say you're using the SDK, you also need to attach the token. There's a security token parameter. That's the only difference you need to do when using temporary security credentials. And the token is what lets us know, AWS, that those temporary security credentials are still valid because they're not tied to a user. They're not tied to a specific account. You can get sessions in multiple ways. So there's a number of APIs that we provide that you can use. The first one is get session token. And this is really if you want to use, you're an IAM user and you want to create a session for yourself. Let's say you want to use multi-factor authentication, you want to do MFA protected API access. This is the API you would use. We also have get federation token. This is one of those, this is the API you would use if you want to build up a federated scenario. We also have a number of assumed role sessions. These are where you create an IAM role and then you call one of the assume role APIs, we have 3 of them today, to assume that role to generate the credentials. Now since this session is about delegating access, I'm going to focus on the APIs that are in the white box. Now sessions are ephemeral. They expire. Okay? And depending on the API that you chose, the account type of credentials or the IAM user credentials you used to create the session, the time frame for those are going to be different. So you want to refer to the documentation and make sure you're choosing an API with an expiration that fits your scenario. For example, if you're using get federation token, the default expiration is 12 hours. You can actually extend that to 36 hours when you make the request. On the other hand, if you're using roles, the default is 60 minutes. Actually, the maximum is also 60 minutes. In all cases, the minimum that you can request credentials are for 15 minutes. Now, because it's possible to create credentials that last for up to 36 hours, I highly encourage you, actually I ask you, to use caching. A lot of mistakes that people make when they first start working with these is for every API request, they go and they fetch another set of credentials. And you can imagine that if you do that, you're going to be introducing round-tripping delay into that. So what I recommend is get the credentials, use an expiration that works for your application, put them on a keychain, cache them somewhere, and continue to reuse them and check your expiration. When they expire, request another set of them. So let's go into role-based delegation using assume role sessions. First thing I want to talk about is roles. How many of you are already using roles? Great. Asked that question last year. I think I had 2 hands. Okay, for those of you who aren't using roles, roles are an entity that defines a set of permissions for making AWS service requests. People understand kind of the concept of a user and groups, and sometimes people come up to me and say, well, is a role just like a group? A role is not tied to a person. Okay? A role is a container for policy. And then you take other entities, like IAM users, or you could take another role, and you trust them. And that trusted entity assumes the role and derives their permissions from that role. There's a number of ways that you can use roles. The first way that we introduced this was like a service role. Actually, the first one was just roles for EC2. But what you can do when you delegate access, you trust a service, they can operate on your behalf. And the way you do this is you create a role, you select the service that you want to trust, and then you apply a policy. And then that service can act within the bounds of that policy, the permissions of that policy, on your behalf. One great way to use this is with EC2. So when you create a role, you can go and launch an instance with EC2. And what that does is we will periodically put temporary security credentials in something we call the metadata cache. And the metadata cache is just a URL. I have it at the bottom of the slide. You can go into an instance, you can curl it, and what that does is it returns back a JSON document that has those temporary security credentials. Now, if you're using the SDK, you don't even have to worry about it. Because if you're building an application with the SDK, and it's running on an EC2 instance that's using roles, it will just transparently pick up those credentials for you. So there's a lot of people today who are still creating IAM users, embedding those credentials in an EC2 instance for their application. And I'm sure you're all rotating those credentials multiple times a day. Yeah, right? No. If you're using roles, you don't have to worry about that. We take care of it all for you. So I highly recommend, if you're currently using long-term credentials on an EC2 instance, if you can, you should move over to roles. So let me show you how you set this up. So I'm logged into my account here, and I'm in the IAM tab. I'm going to go ahead and create a new role. I'll just call this my reinvent, if I can spell, role. And then there's a number of services you can choose from. Last year it just said EC2. Now we have a bunch of them. I'm going to go ahead and select EC2. And so I'm delegating access to the EC2 service, and then I'll just choose the read-only access policy. And so now the temporary credentials that I get from my instance will have all these permissions. Click Continue. You can see the ARN for the role. I'm going to create that role, and then I'm going to switch over to EC2. I go ahead and I launch a role. I'll select the Amazon Linux AMI. Go to the configuration details, and then the only thing you need to do is select the role from the drop-down. So you can see there's my reinvent role, and then I can go ahead and I launch it, and that's it. Now when that instance is booted up, there'll be temporary security credentials from the metadata cache. If you're using the SDK, there's nothing more you need to do. Simple enough? Okay, we're all going to use roles from now on. So there's questions, and due to time, I am going to run to the very last minute. I know that, so I will stick around, and if you want to ask questions, I'll stick around for as long as you want, and you can ask me questions afterwards. So I will take questions at the end. So some of the benefits of the roles, you know, I kind of mentioned this, but it's worth repeating. It totally eliminates the use of long-term credentials, right? You get automatic credential rotation if you're using this with like a service like EC2. And then, of course, because the SDK picks up those credentials, there's less coding that you need to do. Okay? And this is a very simple, secure way to delegate access to AWS services to perform work on your behalf. Now, there's other uses of roles as well. The next use case that I want to go through is cross-account API access. And what this allows you to do is grant access to resources across AWS accounts. So a lot of people don't realize this, but many of our customers have multiple AWS accounts. And they have this for many different reasons. For example, in the most basic case, people will create accounts for, here's my test environment, here's my development environment, here's my production environment. And then inevitably, you have somebody who has to have visibility across all of them. What a lot of people do today is they go in and they create IAM superuser in each of those accounts. And then they get those keys and the passwords and they sync them up and they just do the management of it. Another case is the developer who needs full access to the sandbox, but maybe only read access to certain other accounts. So now you don't not only have to manage multiple credentials, you have to keep in mind which one has read access and which doesn't. The last scenario that's pretty common is if you're using third-party management software. So a lot of our customers use solutions from our partners to manage their environments. And you don't want to be handing over your root credentials or long-term credentials for that. You can use IAM roles for all of these scenarios. Okay? So you can really think of using IAM roles for cross-account access as sort of an extension of what we did for service roles. So when I created that role, what I was doing when I chose EC2 is I was establishing trust. Now that's trust with a service. I can also establish trust with other accounts. I can establish trust within my account. Basically what you're saying is this IAM user or this role in this AWS account can assume this role. And when that entity assumes that role, it will get a set of temporary security credentials with the permissions that are associated with that role. So sometimes it's a little bit easier to think about this with a picture. So this is a real scenario. I have my AWS account, and in there I have an IAM user. His name is Jeff. I'm very creative in that way. And then my team has a team account, and in there I've created a role. Now in both of these accounts I have buckets, and I keep data in S3 for my personal account, and I keep data in my team account. And I want to be able to view all the data across all my buckets, and I don't care which account it's in. And I don't want to have to use multiple credentials to do it. So the way that I set this up is over in my team account, I've created a role. It's called my S3 role. And it's got two policies associated with it. The policy on the bottom is what I call the trust policy. It tells this principal, my account, that I can call assume role. I know all of you went to my policy presentation yesterday, so all of this makes perfect sense, right? If you didn't, you can go see the webcast and you can learn more about access policies. If not, you'll have to trust me that this sets up the trust with my account. Now, when this account assumes the role, these are the privileges that I'm going to get, which basically say I can call any of the S3 APIs on any of the resources in this account. This is only part of the setup. The other half of it is Jeff, in my personal account, also has to have a policy that allows him to call assume role for the role specified. So it's a two-part setup. Two accounts, have to have an IAM user who can call assume role, and then I have to have a role in the other account that allows me to assume it. So we have the trusting party and the trusted party. So what ends up happening is Jeff uses his IAM keys to call STS, and I request a set of temporary security credentials for this S3 role. I get back a set of those temporary security credentials, all right? Those are part of the session. And then I use those, the keys and the token, and I make a request, probably using the SDK, to request objects that are in the bucket in the other account. So let me give you an example of an application that I wrote that allows me to do this. So this is product manager where, so beware. And over in my settings here, I have a set. This is a set of keys for my IAM user, okay? And I'm going to use this one set of keys to assume multiple roles. Now, I warned you, if you're in the back, you're probably not able to see this, so you're going to have to trust me. These are just the ARNs, the Amazon resource names, for 3 roles that I have in 3 accounts that I have access to. And when I launch the application, it calls assume role using these credentials, and you can see down here I have a little timer that tells me how long those credentials will last. When the timer expires, it'll go out and it'll refresh and get those credentials. But now I can do things like expand here and view all the buckets for this account. I can view all the buckets for this account. I have my personal bucket here in my team folder where I keep a bunch of my demos and presentations. I also have my personal account. If anyone came to my session yesterday, you saw that I had a demo where I could drive into my test bucket. In here, Bob's got his home folder. This is where Bob likes to store pictures of my daughter. And so I have the ability to go through and view all of them, and I don't have to have multiple credentials, right? So this simplifies the way that I access information across my accounts. Now, this is just a quick demonstration to show you how to do this with S3. But you can imagine you can use any of the APIs to show all the EC2 instances that I have across my accounts, all the databases that I have in DynamoDB. This is a very simple way, if you're using multiple accounts, to get visibility across all of them. Okay, now for that one, I didn't have the project code. I wrote it up pretty quickly. So I pulled out the relevant pieces for you because I wanted to show you how to assume a role. So when you call assume role, the assume role API, that's an authenticated call. So you need to pass in long-term credentials, or you have to pass in some type of credentials. It could either be from an IAM user or temporary credentials from a role. But I'm passing in my access key and my secret access key. And then I'm making an assume role request. And I'm asking for a duration, which is 3,600 seconds or 1 hour. I'm passing in the ARN of the role. So that's the role in the other account. And then I can give it an arbitrary name so I can identify it. In this case, I'm just calling it my S3 bucket browser. This is a 2 to 32 byte string that you set. And then you make the request, and then from the result, you pull the credentials. And the credentials will have those pieces, the keys, the token, and the expiration. Once I have those keys, I just use them the same way I'm already making API requests. This is the only difference. This is the only thing you would need to do in order to use temporary security credentials for this scenario. So some of the benefits, as I mentioned, you only have to use one set of credentials. If you're working with third parties or sharing your account with others, you don't need to share long-term credentials. And then the nice thing about the role is those temporary security credentials are associated with the role. If I go in and I change the permissions on the role, those permissions are changed on those temporary security credentials. If I delete the role, if I put a deny in there, I'm instantly or effectively, you're instantly revoking access to that user. So next I want to get back to Federation. This is where we started. So I want to show you a little bit how I built that first demo through a couple of scenarios. If you're new to Federation, one of the benefits of that is you get to access AWS using your existing identity. Typically, this is your corporate identity. If you're using Windows, it's probably Active Directory. Why would you want to use Federation? Well, it's a simple way to get into the management console. If you saw, I didn't have to remember any username or password to get in there. You can build applications that transparently access AWS resource and APIs without having to embed long-term credentials into them. And then for your users, it eliminates yet another password to manage and remember, put on a sticky note underneath their monitor, right? So the first use case I'm going to go through is actually going to be API Federation. And just like the previous demonstration I showed, the source code is available for you. So if you want to go ahead and download this and play with it later during your own time, you can do that. In this scenario, we have an identity provider and a relying party. The identity provider is Windows Active Directory. The permissions are actually going to be based off of Active Directory group membership. I'm going to show you how I did that. And then on each of those groups, there's going to be little policy snippets. So I'll explain this in a minute. The relying party, of course, is going to be AWS, and we're going to be doing this to call the S3 APIs. The way that I'm going to get those temporary security credentials with this demo is using Get Federation Token. So this is the walkthrough. I'm going to have this little command line application running on my desktop. And that is going to request a session from a Federation proxy, which is just going to be a web service. It's a Windows Communication Foundation web service running on a Windows server. That proxy is going to have a set of credentials on it. It's an IAM user. I'm going to pause here and kind of describe what happens. When you make a Get Federation Token request, you use a set of IAM credentials. And by default, when you get those credentials back, the permissions associated with those credentials are going to be those of the IAM user. Now, you can also pass in a policy with the request. Now, the policy cannot increase privileges, but it can scope them down. So a lot of times I'll talk about this as being a scope down policy. So you want the proxy server to have credentials with the maximum amount of permissions that any of your users would have. If you're going to have admin users, the IAM account that's used by the proxy server should have IAM privileges. But then for users who don't need that, you'll scope it down. And I'll show you what that looks like in a minute. The proxy server is going to authenticate the user against Active Directory. It's going to determine its entitlements based on its AD group membership. And then it's going to make a request to STS using Get Federation Token. You're going to get back a response. That's going to have the temporary security credentials. I'm going to pass that back to the command line application. And then it's going to make calls to S3 to retrieve objects from a bucket. So I'm going to show you a couple demos that I have for this one. One of them that we wrote, and another one which is actually available from a partner of ours, Cloudberry. Okay, so I can close this, switch over to Visual Studio, and here I have the server. This is, like I mentioned, this is a web service running on Windows, and here's a client application. And let me just walk you through what the web service does. So the first thing that happens is the client contacts it, and the web service figures out who I am by using Windows integrated authentication. So it knows that it's Jeff, right? Then the next thing I'm going to do is I'm going to go and contact STS to create the temporary security credentials. So I have another class in here, and the first thing it does is it builds up a policy. And I'll show you where that policy comes from in a second. And then I use that policy in the Get Federation Token request. And here I'm setting a duration. I think by default I made it 8 hours if I recall. I pass in the username, which is just my Windows username, and I pass in this policy. I have a little helper function here that goes through, finds the groups that I'm a member of, and retrieves policy snippets that I've stored on there. So I'm going to switch over to Active Directory Administration Center, and I'm just going to show you this S3 users group. A lot of people don't know this, but you can go to the attribute editor, and there's an alt securities identities attribute that's not used. So what I've done is I've put a policy on there, and I know you all can read that. Is that better? So this is what the policy looks like. This is what I have stored on that attribute. And I've put in placeholders here for my bucket name and my username. And the proxy server is going to take this policy snippet, and it's going to do just-in-time replacement. And it's going to pass this policy on with a request. So this is how it's going to scope down permissions just that for just that are tailored for me. And so now if I go in here and I run this application, it's going to request those temporary security credentials. It's going to get back those credentials. Okay? You'll just have to trust me. This includes keys and a token. And then if I continue to run it, you'll see that it lists all the objects that were in my personal folder. So this was the same bucket we were looking at in the previous demonstration. And if I want to here, I can tell it to read the contents of a file. Those of you in the front can read that. Thank you. It's sad when people don't clap. Okay, so that's API Federation, and that's a quick sample that we put together, and you can download and play with that. More recently, actually, something that was pretty cool, I found this just an announcement in our forums, is Cloudberry, who's a partner of ours, deployed something, recently released something that they called the Cloudberry Active Directory Bridge. And this is just a web service. I have it running here. They gave me a copy. And this is just a web service that runs, and behind the scenes, this actually uses Get Federation Token. Now, if any of you have used Cloudberry, they've been around for a while, they've included this, the ability to map drives to buckets. But previously, it always required that each user have long-term credentials. So what if you have like 50,000 users and you want each of them to have a map folder, right? Instead of mapping these using long-term credentials, you just talk to the Active Directory bridge. So you run this client, the client talks to that service, it gets back temporary security credentials, and then I can go over here and I can browse. I have a drive, which is my personal folders, and I have a drive, which is a shared folder, and this is just a bucket in S3, and you can do this for all of your users, and you can give them virtually unlimited storage, and to them it just looks like a drive. So it's a pretty impressive little piece of technology that they released. It uses the same concepts that I showed in my sample, but you know, if you want to use something that's real, supported, you can go ahead and you can contact them and use that as well. Okay, so that was using Get Federation Token for Federation. You can also use IAM roles for Federation, and that was actually the first demonstration that we looked at was using IAM roles. And so it's a very similar concept because at the end of the day, you're getting temporary security credentials. It's just via a different API. But one of the differences here is it provides a different option for storing those AWS permissions. So remember, I'll just review this. When you call Get Federation Token using an IAM user, the base permissions are derived from the IAM user making the request and then scoped down with a policy. If you use an IAM user to call assume role, the permissions are associated with the role. So the IAM user only needs the ability to call assume role because the permissions for those temporary security credentials will be associated. You can think of it as being derived from the role. So when you're using this in Federation, it provides sort of a different way to set up those permissions. Something like, you can think of it as almost a separation of duties. Because you might have an AWS administrator who can go in and create the role and determine what the permissions and entitlements are for that role. And then you'd have someone who manages your on-premises infrastructure, you know, like a corporate administrator, and they create the groups, users, and intranet permissions. And the guy who manages your corporate infrastructure, all he can do is reduce permissions. He can't, you know, create those permissions for what you do. So if you have an environment where you want to separate between those, roles is a good opportunity to do that. So the use case that we looked at the beginning was console federation. Once again, I'll put the URL up there in case you guys want to download the code and play with it. Similar scenario, the identity provider is Windows Active Directory. The privileges are based on AD group membership. And then in this case, the AD group must match the name of the IAM role. The relying party, of course, is AWS, but in this case, it's the management console. And the difference in this use case is that we're using assumed role session via assume role. So once again, I think this is a little bit easier to understand with a picture. This looks very similar to the cross-account scenario that we looked at before, but in this case, we're doing everything within one account. Okay? So I have a single account, and I've created a role, and that role, once again, is an S3 role, so I've granted, permissions to do anything in S3 in any of my buckets. And then I've created a trust. Now, in this case, the trust is trusting my own account. So this role is in this account, and I'm trusting that same account. Now, one difference is in here is that I'm using the external ID. So when you create a policy, you have the ability to add conditions. And conditions are additional criteria which must evaluate to true in order for the policy to evaluate to true. And so in this case, I'm requiring that you put in an external ID. And what I'm putting in that external ID is the security identifier, the SID for the AD group. And the reason I do this is if an AD administrator goes and deletes a group and they recreate the group and they put a bunch of users in there, right, that's going to change the SID. And so this ensures that both sides of the handshake stay consistent. And so that's where I'm using the external ID in this scenario. And then, of course, I'm going to have a proxy server that needs to call assume role. And so this proxy server is going to have a different set of permissions than the previous proxy server. It's only going to need to be able to call assume role for any role within my account. And it's also going to need the ability to call list roles. Because if you remember, the proxy server is going to take the intersection of the AD groups and the IAM roles in my account. So these are the only two permissions that I need to grant for the proxy server. And the way this is going to work is the proxy server is going to request a session by making an assume role request. It's going to get back a set of temporary security credentials. And then we're going to use those credentials as a way of logging into the management console. So here's the full flow. This is what we looked at when we started the presentation. User hits the proxy server. As I mentioned, the proxy server has a set of credentials associated with an IAM user. It can call list roles and assume role. The proxy server is also going to authenticate the user. It's going to get back the list of groups that the user is a member of. It's then going to make a series of calls to AWS. The first call is going to be list roles, okay? And then the proxy server is going to get back a set of those roles, and it's going to create that combo box by looking at the intersection of the groups and the roles in my account. I'm going to then choose a role, and the proxy server is going to assume that role. It's going to get back a response. There's only two more steps. I'm going to take those credentials, and I'm going to request a sign-in token. And using that sign-in token, I'm going to create a well-formed URL that will allow me to redirect the user into the management console so that they don't have to provide a username and password. Now, we took a look at this sample, and due to time, I'm not going to walk through the code for this one, because what I actually want to do is introduce that same type of scenario, but using the security assertion markup language. So this is a feature that we released on Monday, and believe me, Monday was busy writing demos and slides for that release. And what this does is it adds open industry support for Federation for the security token service. So for any of you who are using existing identity management software that supports SAML 2.0, you can now use us as a service provider. Sometimes people refer to that as a relying party. And you can use that to either single sign into the management console or do API Federation. Now, the actual profile that we support, it's a mouthful. It's the IDP-initiated web single sign-on via SAML 2.0 using the HTTP post binding. I will never say that again. I'm going to refer to that as the web SSO profile. The other thing we introduced as part of this release is a new sign-in URL. So in the previous slide, I kind of talked about how you had to request credentials, get a sign-in token, generate a sign-in URL. It's well documented, but I've seen a lot of customers have trouble understanding the process of doing that. So we've greatly simplified this in that you just take a standard SAML authentication response. Sometimes I'll refer to this as an assertion. And you pass that assertion to our new SAML sign-in URL. And there's nothing you need to do. The user then will, if you provide a single role, they'll just be transparently logged into the console. If you provide multiple roles, they'll be presented with a list that they can choose from, and then they just SSO in. So I'm going to show you a couple scenarios using SAML. Won't walk through the entire flow, but you can tell from the number of lines, it's greatly simplified compared to the previous state. Some of the steps are the same. You know, you're going to take a browser. In this case, you're using some standard identity provider. In my example, I'm going to show you using Windows Active Directory Federation Services, ADFS. It's a basic role that comes with Windows Server. That's going to authenticate the user against the directory. In this case, it's going to be Windows Active Directory. It's going to pass back the auth response, the assertion, to the browser. That browser is going to post it to sign in, that SAML sign-in URL that I showed, and it's just going to be redirected into the console. So it's a little bit simpler flow. So let me take you through that. Now, the first step is just configuring this. So let me go over to IAM. If you haven't logged into the IAM console lately, you probably didn't notice that we added this Identity Providers tab. And so this is where you go and you create your SAML provider. Now, the way that you create a SAML provider is by uploading a standard SAML metadata document. This is just an XML file that describes the capabilities of your IDP, your identity provider. And you name it, so I'll call it my SAML provider. And then you upload the document. Now, you get this document from your IDP. In my case, I'm using Active Directory Federation Services, so there's just a URL you go to download it. I've already done that for time, and I select that document, and then I create it, close it, and now I have a provider, so my SAML provider. And if you look at it, all it is a container for that configuration. It allows us to know who we're going to trust, in this case, your IDP. And by uploading that, you get this Amazon resource name. I point this out because I'm going to use this in one of the steps in the demo. Now, the way that you complete the trust on the AWS side is you go and you create a role. Okay, so we have a new role type, so I'm going to create a role. And I'll just call this my SAML role. And then I'm going to choose a role for identity provider access. And here I'm going to grant web single sign-on, web SSO access to a SAML provider. So I'm going to select that one. And now the provider that I just created is available in the list. Okay? So I can select that one. And then there's certain SAML attributes that you can use as conditions. Now, since I'm using web SSO, what I want to ensure is that the SAML audience, where this should be directed to, is our sign-in URL. And so since you chose the web SSO profile for that role, we're actually going to add that in for you automatically. So I click Continue. This creates the trust policy. So once again, we're just trusting this SAML provider, which I just created. And we have one condition is that the audience, where it's targeted, should be sign in. Click Continue. I can choose the template, the policy that I want to grant them. Maybe I want to give them admin access. And so this creates the access policy. Continue. And then this is the role that's going to be created. So I can go ahead and I can create the role. So this is what you do to establish the trust inside of AWS. Now, you also have to set up trust within your identity provider. Okay? So I'll show you what this looks like with ADFS, but obviously this is going to depend on what you're using. Let's say you're using a Ping, an Okta, simplified, one login, or something like that. They're going to have their own set of steps that you need to go through to configure that side of the trust. But here I'm just using ADFS because it's convenient. And what you do is you go in, good old Windows. Thank you. Okay, so you go in here and you create, you add a relying party. And remember I talked about using the IDP's metadata document to create the SAML provider in IAM. There's a similar process where in your identity management software you need to import the AWS metadata document. So you can get that, and if you ever forget, this URL is in our documentation. You just go to this URL, this pulls down, and this is basically our certificate, and it's our configuration that you need to import. And so it's right off of sign-in, static, SAML-metadata document. Like I said, it's in the docs if you forget it. You download that, and you import it into here, okay? And then here you can see where the URL is that ADFS will pull it from. And so now I'm a relying party in the eyes of ADFS. Now you have to be able to generate a SAML authentication response. And the way that you do that is by creating claims. This is the ADFS nomenclature. So I'm going to go ahead and create some claims. There's 3 attributes that you need to send to us. One of them is the name ID. And this one you can simply use through the UI. I'm mapping the name ID to the primary SID, the security identifier for the federated user. Okay? The next one that I'm going to do is the role session name. Remember, when you call assume role, you can apply an identifier to that. And so that's the role session name. And in this case, it's this attribute. And I'm just going to use the user's email address. And I'll show you in a minute where that gets used. The last claim that you have to send over is a little bit tricky because you have to send over the principal, the SAML provider that you want to use, and you have to pass over the ARNs of each of the roles that you want to assume. And to do this, I created 2 custom rules. And it's probably a little bit beyond the scope of this presentation to walk through the code, so I'll just kind of describe it. The first one goes through and it queries AD for the groups that I'm a member of. And I do a very similar matching between the AD groups that I'm a part of and the IAM roles that are in my account. And then I take those groups and I transform them so that I'm sending over the SAML provider, the one I created, and the roles that I want to assume. And so what this looks like again in AD, you know, I'm a member of a group called AWS Full Access, and I'm a member of AWS No Access. And then back over in my AWS account, I have a role, ADFS Full Access and ADFS No Access. And so what it'll do is it'll look for groups that are prepended with AWS dash, and it'll try to assume roles that have ADFS dash in my account. And so now I'm going to go over here. Let me just sign out. And I'm going to go to the ADFS sign-in page. Now, I didn't do anything. This is the default page that comes with ADFS. Since I've configured myself as a relying party, it's in the list. It's using integrated Windows authentication, so it knows who I am. And I can just click Go. And there are the 2 roles that were passed over with the assertion. I can choose the full access one, click Sign In, and then kind of like the previous proxy example, I do single sign-in without having to provide a username and password. Now, I talked a little bit. It gets truncated over here. You can see this is the name of the role that I assumed, and here's the password that I passed over as part of the role session name. So that's where those attributes get used. But now I'm in the management console, and I can do whatever I want. So that's one way of doing single sign into the console using SAML. I also want to show you how you can do this programmatically. So let me just clean up a few things here. So folks use the AWS CLI? Yeah? Okay. A few CLI users? Okay. So one of the things about the CLI is you have to pass it credentials, right? So what if, you know, I simply wanted to list all my S3 buckets? Unfortunately, I don't have any credentials on this machine, and I'm not using a role. So what if I wanted to use SAML as a way of getting temporary security credentials, pipe those into the command line interface, and then I never have to use long-term credentials with the management console again? So what I've done is I've written a small little wrapper. It's actually this SAML CLI.exe. And to simplify it, I created a batch file, and I'll just show you what that looks like. And what the batch file is going to do is it's going to tell my executable a few things. First, it's going to give it the identity of my ADFS server. So this is just the URL to that server. Then I'm going to tell it the SAML provider, the one that I configured in IAM, that I want to use. And then I'm going to specify the role that I want to assume. Okay? And then these here are just whatever you were passing on to the command line interface. So I'm going to take that batch file, and I'm going to say the same command, list my S3 buckets. And it's going to go out, it's going to request a temporary security credential, it's going to take those credentials, it's going to pipe them into the AWS CLI, and I'm going to be able to issue that command. And I can go in now, and all day I can just run whatever commands I want. And I never have to give my users long-term credentials to be able to do this. It's simply, every time it's going out, it's requesting credentials from my IDP. So how did I do this? So let me just set this as the startup project. I'll go ahead and run it. So the first thing I need to do is get a SAML token from my identity provider. Now, it's a little bit outside of the scope of this presentation for me to teach you how to do this with ADFS, but trust me that I just created a helper class that goes out and requests that from ADFS. And what that does is it sends me back a base 64 encoded token. So this is just a SAML assertion, which is an XML document, which is then base 64 encoded. And then I take that, and I'm going to request temporary security credentials. Let me give you guys a little bit more visibility. I'm going to request temporary security credentials from STS. And when I get those credentials, one of the things about the command line tools are you can set environment variables for the access key ID, the secret access key, and the security token. And a nice thing about doing it this way is when I set those environment variables, they have a lifetime of the executable. So once the executable is disposed, those environment variables disappear. So they're not lingering around anywhere. And so I can go ahead and I can set those environment variables. And then here I have just a little helper class, which I'll show you. It just calls the AWS CLI in a separate process, collects all the standard output, and then writes it out to here. And so that's how I'm capturing it. So I'm essentially just wrapping that. And so if you already have a solution that supports SAML, you can build this type of solution, and you never have to use long-term credentials to drive the CLI again. Okay, so that was a couple federation scenarios. Showed you API access, also using SAML. Now, those are sample code. You can go ahead and you can write those. I'm also happy to say that we have a number of partners who provide commercial software in this space, many of them who are in the partner forum. So if you're interested in seeing something that has 24/7 support, I encourage you to go ahead and visit their booths. The last use case I want to go through is Web Identity Federation. Anybody here creating mobile applications or thinking about creating mobile applications? Okay, a couple hands. All right, so let's say that you want to create a mobile app, and you want to create that app, and it's backed by AWS. Maybe you want to build an app, a game that has a leaderboard, or maybe you want to do some type of file sharing application, or maybe you have some like a book reader, and you want to share state between your iPad and your iPhone. There's a number of challenges in creating mobile applications and using AWS as a backend. So first, those users may or not be authenticated. Probably guaranteed that your end users don't have an AWS account. So what you're going to do is you're going to delegate access to those users. Like say you're creating a leaderboard. I am going to create a mobile app. I am going to create a database in DynamoDB in my account, and I'm going to allow those users to store information in it. Right? I'm financially liable for what those users put into that database. So there's some good ways to do this, and there's some bad ways to do this. Right? Typically, unfortunately, a lot of people will embed credentials in the app. You should not embed credentials in the app because those are easily extractable, and then someone can take those credentials and do whatever they want with them. Right? So you don't want to do that. So what a lot of people did then is they would create proxy servers, which is a good, safe way. You put an intermediary into the solution, and your application calls that proxy server, and it interacts with AWS on your behalf. A better way of doing this is using Web Identity Federation. And what Web Identity Federation allows you to do is authenticate a user with a well-known public identity provider, like logging in with Amazon, log in with Facebook, or Google. And when you do that, we allow you to request temporary security credentials without having to use long-term credentials. Okay, let me show you a diagram that explains this a little bit better. So let's say you have a mobile application, right? And that mobile application is going to authenticate with login with Amazon. Okay, so users are going to log into your app using their Amazon username and password, the same one they use to log into the Amazon retail site. And what's going to end up happening is when they authenticate, they get back an ID token, right? So this is a pretty standard way. This works with Amazon, Facebook, and Google. They'll pass you back this token. And what we allow you to do is make an assume role with web identity request. And this is similar to the assume role with SAML in that it's an unauthenticated request, and it's an anonymous request. Because you're passing the token, that's what identifies you. Okay, so here you don't have to have any long-term credentials in your application to make this request. You just have to have a valid token from the identity provider. And then on the back end, we take that token and we send it over to those identity providers and we say, is this valid? You know, is this really who they're supposed to be? And if they are, they provide us additional context, like who is the user? What is the application they're trying to use? And that context then becomes variables that you can use in your policies. And if you don't know what policy variables are, I encourage you to go back and see my webcast from yesterday. So we get that back, and then we check it against the policy. We make sure that it's valid with the trust that they're trying to assume. And then we send back your application temporary security credentials. And just as we've seen, once you have those credentials, you can rock on and you can call any of the APIs that you've associated with the role. So some of the benefits of Web Identity Federation. Obviously, you get to create mobile. This also works. I'll take a pause here. We built this for mobile applications, but is anybody using the new JavaScript SDK that came out? Yeah. This is another great use of assume role with Web Identity Federation. Because if you're building client-side web applications, you have the same constraints. You don't want to expose your credentials in that. So if you are creating client-side driven applications, you can do the same thing where you log in with Amazon, Facebook, or Google. Those are the 3 providers that we support today. And then you get temporary credentials. And so then you're not exposing long-term credentials to your web-based apps. But if you're creating mobile or web-based apps, this is a great way to do this. It eliminates the need to directly embed credentials in your app or your website. And it also eliminates the need to deploy and maintain those proxy servers. I'm not going to show you a code sample of this one today, but it does have the assume role with Web Identity API. What you do is you create a role for each of your applications. So when you create an app and you register it with, say, a Facebook, they'll give you back a unique application ID. For each of those applications, you create a role that trusts that identity provider. And then you place an access policy on that role, which determines what your users can do. You know, read from a bucket, write to a table. If you're interested in this, I highly recommend you go to, it's the afternoon session, 1:30, back in this room. It's Security 401. Bob Kinney's going to do an entire session on building mobile applications. He does it much better than I do, so I highly recommend if you're interested in that topic, you come back here after lunch and you can learn more about that. Now, we're getting down to the bottom, and I want to say a few final words on using temporary security credentials. First of all, I want to be completely transparent. Are there any limitations to using sessions? Today, there are a couple services that don't support temporary security credentials. By and large, all other services do, but if you're using Elastic Beanstalk and Elastic MapReduce, I just want to warn you in advance. Today, you do need to use credentials from, say, an IM user. You'll find that even if you log into the management console, we block those services if you're using single sign-on. So that's one limitation we have today. We hope in the near future this will be 100% coverage. The other thing is the difference between a federated session and an assume role session. So if you're using get federation token, you can get sessions that last for up to 36 hours. Okay? And for your protection, we don't allow you to call the security token service or identity and access management, because those are pretty privileged APIs. Like if someone were to take those temporary security credentials, by mistake you expose them, they could then co-create users in your account. So by default, we don't allow you to call STS or IM using federated sessions. Now, assume role are scoped. You can only create a session that has a lifetime of 60 minutes. And so there, it is possible to create temporary security credentials that are privileged. You can call IM, and if you assume a role, you can use those temporary security credentials to then make subsequent calls to assume role. One common scenario for this is, let's say you take a role and you launch an EC2 instance. You can then what's happening in the back end is EC2 is making an assume role call to put those credentials on your instance. You can then take those credentials and call multiple roles. A common question I get is, can I launch an instance with multiple roles? You can launch an instance with one role, but then that one role can make subsequent calls to assume role if you need to get different sets of permissions for your applications. So that's one way of working around, and that's one of the things you can do with it. Okay, in summary, we looked at a number of scenarios. One of them was the cross-account API access. Just to remind you, this is a great scenario so that you can use one set of credentials and you can use them to access any of your resources. You don't have to share long-term credentials with your coworkers, with your business partners. We looked at a number of federation scenarios, whether you're using single sign-in to the management console or API Federation. This allows you to use your existing corporate identities to access AWS resources. We also looked at how you could use SAML, an open standard, to do that. And the last scenario we took a look at was Web Identity Federation. And you remember, this is the ability to log in with a public identity provider like Amazon, Facebook, or Google and do federation. If you want some additional resources, of course, you can always go to our detail page. Our documentation is fantastic. If you're using this and you have questions, I hang out in the IM forum quite a bit, so if you're having problems, there's probably a pretty good chance that I'll reply to you personally. And then, of course, we put a lot of additional information into the AWS security blog. If you're not already following our blog or following us on Twitter, that is where we're going to put all of our announcements. So with that, we did have a bunch of sessions. This is kind of the last in the series, though I do encourage you to come back in the afternoon if you're interested in the mobile one. I'm running low on time, so I will stick around afterwards to take questions. But if you find that you don't have time, we're also going to have the IM and security team in Toscana, 3605, just upstairs at 4 o'clock today. So if you want to meet with me or the members of my team, we'll be there to talk security with you. And with that, I just want to say thank you for sticking with me for the last hour.